common emitter output characteristics. So there I told you that when we are using common emitter configuration, okay, this is my emitter, this is my base, this is my collector, okay. So when I'm using this common emitter configuration, my input current is IB, okay, output current is IC. So if beta is given, then my IC will be simply beta into IB, okay. And yesterday I was discussing these graphs, okay. So these graphs actually are not parallel, okay, for common emitter configuration, okay. They have slightly slope, they have slight slope, okay. So slight slope means the output characteristics of a common emitter configuration, okay, have a slightly lower resistance than common base configuration, okay. So common base configuration, they are slightly straighter, that means they have higher resistance. Here they are little bit like some slope is very small slope is there. They also have a high resistance, okay. Output has always high resistance, but compared to common base configuration, this configuration has a slightly less configuration. But since current gain is very high, okay, in there we have input current IE and we have output current IC, okay, they both are almost equal. But in this case, okay, the current gain alpha is less than 1, okay, almost equal to 1, okay. But here in common emitter configuration, the current gain is beta, that is IC upon IB. That is, you are you have some IC, okay, IB value 10 microampere. If your beta is 100, you multiply 100, you get 1 milliampere current, okay. So current gain is very high. That's why this common emitter configuration have a high voltage amplification and high power amplification, because current gain is high. Although the resistance is smaller compared to common base configuration, but still that is amplification purpose, this is the better configuration, okay, or this is the preferred configuration in transistor, okay. So this is the one thing. And other thing, yesterday we were discussing that if my my VCE is close to 0, okay, 0 or close to 0, so that is your saturation region, okay. So we always need to check that what is the VCE value, because VCE value will ultimately decide, okay, what is VCE, okay. This VCE will decide where what is actually VCB and what is VBE, okay. So VB is always fixed. So if VC is 0, then VC will become 0 minus 0.7. Then this NPN transistor become forward bias. That will become FR biasing. So this will automatically become saturation region. Okay. So VC value should not be close to 0 if you want to avoid saturation region. For example, if you are silicon transistor, germanium transistor, so germanium VB is 0.3. So if your VC is 0.3, that 0.3 is coming here. Here you have 0, okay. Or suppose less than 0.3, then this saturation. For silicon itself, it has this is 0.7. So if VC is less than 0.7, so this will make this junction as a forward bias, okay. So we have to check. So we want to check, we want here VCB should positive, because the NPN transistor, okay. So the VC should be like such that the VCB should be positive here. If VC less low, then VCB will become negative. That will give you forward biasing, okay. So that will go in saturation region. We'll do some problem, then you'll understand. This point is clear or not, what I told? Is this point clear?
Yes.
Now let me give you some problem, and I will tell you how to, okay, find out operating point. Suppose I have this common emitter configuration. This is my base, okay, and this is my collector. Here I have a resistance, here. Then I have one more resistance here. Okay. And here we have a battery 10 volt. This resistance is 3 kilo ohm, and this resistance is your 200 kilo ohm. IB 200 kilo ohm. So I'm giving these values. Okay. Now you need to tell me that what is the, this is the VCC. Okay. This is the VCC, and here this voltage is given as 5 volt. Now this says find the this is common emitter. Find the operating point. Find the operating point. Okay. Now operating point means you to find, okay, Q that is BCE and IC value in the circuit. So this is your base. So your this current is coming here. So this is IB is coming. Okay. Similarly, IC is also coming. The current which flows through the current terminal is called IC. Okay. This is your IB and this is your IE, which is coming out. Okay. Now, just now I have drawn some characteristics. This is your VCE and this is your IC. Now, what do you mean by your operating point? This is your operating point. Okay. This is called your Q. Okay. Operating point, which is a VC and IC. Okay. So some IB current will come from circuit. Okay. If the beta is given, so you can find IC. What is the IC? So in this particular question, beta value is given you 100. Beta value is given 100. Okay. Now you can see here we have a resistor also in the circuit. Okay. So if I write a KVL in this equation, if I say this is my VCC, okay, so I can write what? Minus VCC. This is this is RC, okay, minus ICRC. Here voltage drop is VCE, okay, so plus VCE plus VCE equals to 0. Okay, at output terminal. So when I see this equation,
सर ये एक और बार बताओगे कैसे मिला?
ये minus VCC, okay, plus
Yes, sir.
plus ICRC, okay,
Okay, sir.
plus VCE, plus VCE, okay. Now if you see this
Okay, sir.
equation, from this equation, your VCC is your VCE is your VCC minus ICRC, okay. So you have some battery here. Okay, if you know the current, you can find out how much voltage drop here. Remaining voltage will come here VC. Okay, so this voltage finally drop here, and then there's some drop here VC. Okay, so I have written this equation. So basically this point is your VC, and V is in 0. Okay, so VC basically your VC. Here I is 0, no resistance is there. So basically your VCE and VC are same in this question. Okay. Now if you see this equation,
For
this is
output
the
terminal.
this is output terminal. Okay. So this is, if you see this equation, this is a line equation. Okay. Y equal to minus mx. So this is the basically your equation of a line. Okay. Now if you see, if you put IC equals to 0 here, if you put IC equals to 0, your VC will become VCC. So this end of this point, okay, this is your voltage is your VCC. Okay, if you put IC equals to 0 here, then your VC equal to VCC. Similarly, if you put your VC is 0, then at this point, whatever your IC is there, okay, whatever your IC is there, that will become your VCC upon RC. Okay, and that is called your I saturation current. This is called your I saturation. Okay, now what do you mean by I saturation current? Okay, so whenever your VC is 0, okay, then this equation, this equation limits the maximum value of current here. Okay, so this is your maximum value of current. Okay, which is equal to VCC upon RC because VC is 0. So this is the end point of this line. Okay, and this is called your DC load line. DC load line of the circuit. Okay, now operating point can be somewhere here. Okay, this line is fixed. Okay, operating point can be anywhere depending on the value of resistance.
सर
Okay,
ये
value of हाँ,
सैचुरेशन करंट वाला बता दो दोबारा.
सैचुरेशन करंट का मतलब है कि जब भी VC 0 होगा, ओके, तो ये जो करंट लगा ये that is called IC saturation. VC is 0 means your current is IC saturation. So in output this is the maximum current value. If current is coming more than this value, that means you are that will be in this line. That means your VC become negative. That means you come in saturation region. This is the maximum value current you can allow. We'll discuss now. So this is your, whenever you make VC 0, so whenever I ask you in the question, please make calculate the IC saturation value, then you immediately you have to make VC 0. Okay, here and here maybe any resistance, here maybe resistance, but for saturation you need to make this two terminal short. Okay, once you make these two terminal short, then VC becomes 0 and you can calculate VCC by RC, you can calculate the current. Now here resistance RC, here maybe one more resistance here, then VCC will be RC plus RE. Okay, that we'll see later. So now let us solve this circuit. Okay, it's very simple. Okay, so now you have been given everything. You have been given the biasing in both the side. Okay, you have been given resistance. Now you have two loops. Okay, that is the input loop and that is your output loop. Now beta is given, so first you need to calculate your IB value, and you know that VB is always 0.7. This is your VB, it's always 0.7. Okay, so now it is very easy. Just you have to write two equations. Okay, always you have to write two equations, one for input, one for output. Okay, write for input equation. For input you can write -5 plus 200 kilo ohm into IB, okay, plus VB, okay, voltage of B with respect to E, VB equals to 0, and this will give you, okay, IB value. What will the IB value now? IB value will be 5 minus this is 0.7 upon 200 kilo ohm. Okay, this is your IB value. So calculate what is the value of IB. This will give me what, 4.3. Okay, and this becomes 2 into 10 raised to power 5. So
सर 0.7 वैल्यू दिया है.
VB हमेशा 0.7 होता है. मैंने बताया था ना, कट ऑफ वोल्टेज के बराबर होता है. ओके,
हाँ,
VB
okay, sir.
for silicon it is 0.7 and for other thing it is 0. Germanium it is 0.3. Okay, now tell me how much current is coming. So this will come what, 2.15.
2.15.
Okay, 10 raised to power minus 5 ampere. Okay, and this will become 0.215 if I divide by 10, multiply by 10. Okay, so divide by 10, multiply 10, so this will come 21.5 microampere coming current. Check it. Okay, so IB will always come in microampere. Okay, IB is very low. Now once I know IB, now it is very straightforward. If I know the beta, I can calculate IC. So IC is what, beta IB. Okay, beta is given in the question 100. 100 is given, and this is your this one. Okay, so 100 into 21.5 microampere. Okay, and this will give you how much? This will give you 2.15 milliampere current. Okay, now you know the IC. Okay, now how to find out operating point. Okay, whether this IC is the IC what we are searching. Okay, so now we have to find first whether our transistor in saturation or not. Okay, so the simple technique I'm telling you, that technique you to apply, okay, that will give you automatically result. No need to check what is BCB here, what is BCE here, that you don't need to check. Okay, you have to check only one thing, and that is applicable to every configuration. You just find out IC saturation. Okay, so I have calculated IC. Now you find out IC saturation. IC saturation, and IC saturation is what? When you make BC 0 here. Once you make BC 0, automatically this becomes VCC upon RC. VCC is your 10 volt, RC is your 3 kilo ohm. Okay, 3 kilo ohm. So this becomes 3.3 milliampere. Okay, so whenever your IC calculated, okay, is less than IC saturation, that time the operating point, the region of operation will be active region. That will be in active region. Okay, no need to check other things. This is sufficient. If you check this one and IC is less than your IC saturation, then automatically your operation region is active. Okay, I will tell you how now. Okay, so now for active region, what are the conditions I told you? For active region, you need to BCB should be positive. Yes. हाँ.
वो
Yes.
लेस देन हुआ तो
कहाँ पे? तो IC लेस देन तो है. IC should be less than
वैसे
IC
सैचुरेशन लेस
हाँ. Yes.
अपोजिट
One by one, please ask one question. Who was asking?
सर आई एम
हाँ.
वरुण सर इसका अपोजिट हुआ देन
अपोजिट बता रहे हैं ना, अभी आगे क्यों भाग रहे हो? ठीक है, अभी तो बता रहे हैं कि IC is less than IC saturation, then you have the operation region is your active region. Okay, now we can check here whether really it is active region or not active region. Okay, so for active region, what I supposed to know? Okay, what is the condition? Active region, I made a one table in the beginning. Okay, so there is one written input should be forward bias and output should be reverse bias. Okay, input means ammeter based junction and output means collector based junction. So now this collector based junction should be reverse bias. Now this NPN is, and this is NPN transistor. That means here VCB should be what? Positive or negative? VCB value should be positive or negative?
Positive.
Positive. Okay, so just now you have applied loop like this. You can apply loop like this also. So this is your VCB. This is your VCB here. This the voltage between collector and base is called VCB, and this VB. So you can take this loop. Okay, so now again you have minus 10 volt. Okay, plus ICRC. Okay, IC value just now you calculated 2.1. Okay, or let me write completely that if you mistake. ICRC, say this is minus VCC. Okay, ICRC, then plus VCB and plus VBE. Okay, equals to 0 because VC is equal to VCB and VBE. Okay, so we can write loop equation like this also. Now from here I want to calculate VCB value. So I have VCC 10. Okay, IC is given 2.115 milliampere. RC is given 3 kilo ohm. Okay, plus VCB, and VCB is your 0.7 equals to 0. Now what is the VCB values coming? Calculator, tell me. What is the value of VCB? What is the value of VCB?
4.25 4.25
2.85.
2.85. Okay, very good. Okay, so your VCB is 2.85. 0.85. Okay. So now this you have a VB 0.7. Here also you have a reverse bias, powered by reverse bias. Okay, that means reverse bias because NPN transistor. This is for plus means reverse bias. Okay, so you have FR biasing. And whenever you have FR biasing, the operation region is your active. Okay, so no need to check this one also. Once you calculate your IC is less than IC saturation, automatically your operation region is an active region. Okay, this is the first thing. Now what happens if your IC is greater than IC saturation? Okay, so if your IC is greater than IC saturation, okay, then your operating point, then the region of operation will be your saturation region. Okay, then it will be saturation region. Okay. Okay. So but that time you have to remember that time your operating point. Now in the previous question, let us discuss first previous question. Okay. So now we have calculated IC. Okay. Now I need to calculate second loop. I need to calculate what is the VC value of VCE. VCC is my VCC minus IC RC, and VCC is my 10 volt. IC just now I calculated how much. What was the IC? What is the value of IC? 2.15 milliampere. Okay, and RC was my 3 into 10 to the power 3 kilo ohm. So what is the value of VCE? Calculate. So it should come around 3.45 volt. Check it. 3.55. Coming?
Yes, sir.
Okay. So now you know the you say my operation point is activity region, and my operating point is what? My operating point is VCE 3.55 and my IC 2.15 milliampere. This is my operating point. Okay. This up to this is clear or not? Okay.
Yes, sir.
Okay.
सर
हाँ
सर ये VC इक्वल टू VCC माइनस ICRC
हाँ
ये कैसे लिया?
अरे यही तो अभी थोड़ी देर पहले तुमने पूछा था, इसी लूप पे लिया ना भी, ऐसा भी आ सकते हो, ये लूप है VCC ICRC VCE,
ओके
ये
ओके
इक्वेशन है
सर
ना, लूप की इक्वेशन है ना.
ओके सर
नाउ
तो सर VCB के लिए कौन सी लूप ली थी? VCB के लिए भी यही लूप ली थी?
ये वाला बार वाला आउटसाइड लूप
ओके
VCC ICRC, which is VC is equal to VCB and VBE. Okay.
ओके ओके
Okay. Okay. So just for checking, for check whether it is correct or not correct, you can confirm by checking the value of VCB. But that once your IC that's an saturation, that is confirmed the region is active. Okay. Only how much is active? It is close to saturation, or for that we have to see. Okay. But it is, if IC is less than saturation, your operation region is active. Okay. So this is the one thing. Now second thing I was telling, whenever your IC is greater than your IC saturation, okay, in that case your operation region will be saturation. That is sure. Okay, but then what will be your operating point? In that case your operating point will be simply 0 into VCE. Okay, because you are calculating IC saturation, making it 0. Now when you're applying this kind of battery, this cannot be negative. Okay, like just now I have drawn these characteristics. Okay, I told you the end point in this graph. This is your IC and this is your VCE. Okay, so these are your end point. This is your IC saturation. Okay, and this is your VCC. So whenever you get IC greater than IC saturation, So IC actually cannot be greater than IC saturation in this loop. Because this cannot be negative, na? When you're applying here voltage drop, this cannot be negative. So IC cannot be greater than IC saturation. So whenever you find a circuit, you're getting IC greater than saturation. That time you put, okay, your maximum, your VC equals to 0, and current is equal to IC saturation. Here this is your operating point. Okay, so your VC will be 0, and your this will be operating point will be 0 into IC saturation. Okay, because if this IC is greater than this IC saturation, then what will happen? This become VC. Okay, and this will also come negative. We'll check that. We'll check when we do problems. Then we'll see. Okay, if IC is greater than IC saturation, that time this value will come very high value. Okay, so this value will make this negative, or you can say this is negative. So that's why this is also you are in this left side of this graph. Okay, that's why VC is somewhere here. So VC becomes your what negative. Okay, so VC negative will make VCB negative. That will become forward bias. Okay, so let me solve one problem that time we will discuss. So in this particular question, my operating point is in active region. Let me give you one problem. We have a transistor, okay, which is in 10 kilo. I have this one VCC 5 volt. Here you have a 1 kilo ohm resistance, and this is your 10 volt, and beta is given you 10. Okay, so please find out what is the operating point, find region of operation, find region of operation, and operating point. Calculate. So I give you 5 volt this time. Okay. Okay, just wait 1 minute. Okay, here you have 10 volt. Okay, okay, this is 5 volt. It's the same question. Do it. This first question you check it. Tell me what is the operation region. So how to write? This is here IB is coming. Here your IC is coming. Here your IE is coming. Okay.
Sir,
So
5.7 volt and 4.3 milliampere.
yes, very good. Okay. So and operation region is active. Okay. So if you calculate IB in this loop, so IB will be very good. What? 5 minus 0.7. This is 0.7. Okay. And you have 10 kilo ohm. This will give you what? 4.3, okay, into 10 raised to power minus 4 ampere, okay. Or you can say this is your 4.3 if I want to divide by 10, okay, so this is 4.3, correct, and here 10 kilo ohm, 10 is okay. So how much will come? It will come 0.43 milliampere, okay. Now I know what IB, so I can find IC. IC will be simply beta into IB, that is 10 into 0.43, okay, that is 4.3 milliampere, okay. Now IC saturation for, okay, you have to make VC 0, VC 0, okay. So once VC 0, your IC will be VCC upon RC, okay. So IC saturation will be, your VCC is 10 volt, that is 1 kilo ohm, okay, that becomes 10 milliampere. So my IC is less than IC saturation, okay. So that means my operation region is active, okay. Now I want to find out the operating point. IC already I know, okay. So once I know the IC, I can find out VCE. VC is nothing, that is this VCC minus ICRC, okay. VCC is 10 volt. IC you already calculated. Now how much? What are IC? 0.43 milliampere, 0.43 milliampere, and RC is your 1 kilo ohm, that will become 10 minus this cancel 0.43.
Sir, that was IB.
Okay, this was 4.3, yeah.
Yes, sir.
4.3, so 4.3, okay, that will come your 5.7. So your operating point is, okay, 5.7, and IC saturation is your 4.3 milliampere, okay. This is your operating point. Now for this IC you can check BCB, okay. If you want to confirm that NPN transistor, what is the sign of BCB? So so already you can see here na, so this is your 5.7 and this is 0.7, so automatically here it's come 5 volt, isn't it? Your this VCE is equal to VCB plus VCE. VCE equal to your VCB plus VBE. Now you know your, this is your 5.7 and this is, you want to calculate VCB, and this is 0.7, so automatically coming plus sign, that means it is reverse bias, okay. So you can always confirm, okay, that your this is forward bias, okay. And VC also is 5.7 volt, okay, that also making you confirm, okay, because this is your graph.
हेलो सर
Yes, हाँ,
साउंड प्रॉब्लम हो सकता है
साउंड में प्रॉब्लम हो रहा है.
हाँ सर सीसी
Hmm. So you can check your VC is 5.7, VC is not close to 0. So when there is a VC close to 0, then only you should doubt whether it is active region or saturation region. Okay, that means the VC should be around close to 0.3 or 0.6, 0.3 for the germanium and 0.7 for the this your this. So you can assume if whenever you VC less than 1 volt, then you should be a little bit careful. You should properly calculate whether active region is saturation or that was active, okay. Otherwise this is a very high value 5.7, so it is here. So once here, this is your active region, okay, clear.
Sir, sir, एक doubt clear करना. VCB is positive. VCB is positive, so that's why it is reverse bias, and that's why we are saying that this is
Yes, yes, obvious na. Definition is what the table is I made first na. FR raising, FR biasing saturation, FR reverse bias saturation, that is your active region. So your, for amplification, the forward should be, this should be forward bias, and it's already forward bias, we can see, Okay, with very high voltage, this require only 0.7. So forward current is flowing, and this should be reverse bias ammeter base junction. So VCB is NPN. So N should be connected with positive. That then only it will be reverse bias. So VCB is positive. That means it is reverse bias. NPN transistor. If it is PNP transistor, then VCB should be negative. Are you getting my point? Okay.
Yes,
That
thank you.
we have to see transistor. So now this particular question. Now what I'm making. I am making this as a 10.7. Okay. Now again you find the region of operation and active region. Calculate. Find out the region of operation and cutoff region. So the question which I am solving here, that came here June 2017 net. So I take this input loop. I have this minus 10.7, okay, plus VB, okay, that is 0.7, IB plus IB RB is given 10 kilo ohm, 10 kilo ohm, okay, 10 kilo ohm plus VB equals to 0. Now VB is your 0.7, okay, so you want IB. IB will be 10.7 minus 0.7 upon 10 kilo ohm. So that will give you how much? 10 upon 10 into 10 to the power 3. Okay, it is coming around 1 milliampere. Okay, and 1 milliampere is quite high value for base current. Okay, now beta value is given 10. Okay, beta value is given 10. So your IC will be 10 into 1 milliampere. So your IC become now 10 milliampere. Okay, so now this is very quite IC, quite high value IC. Okay, now you want to find out IC saturation. Okay, IC saturation, and IC saturation nothing 10 upon 1 kilo ohm, 1 kilo ohm. Okay, so what is the value? What is the value?
10 milliampere.
10 milliamps.
This is also coming 10 milliampere. Okay, so both become same in this particular question, isn't it? So in that case, just 1 minute. IC saturation is 10 upon. Okay, you just make it 2. This is 2 kilo ohm. Just make it 2 kilo ohm. Okay, so you make 2 kilo ohm. So this become your 5 milliampere. This become 5 milliampere. Resistance I have changed. Okay, you can make 10 1 also, no issue. Then it will be then also saturation. Okay, so now this become no flip this question. Your IC become greater than IC saturation. Okay, so the region of operation, okay, become your saturation region. The region become your saturation region. Okay, now if you want to check, you can check. Okay, suppose you put now, you apply loop here, you have minus 10 volt. Okay, you have 2 ICRC, 2, okay, 2 into 2 kilo ohm. Okay, IC value just now we calculate 10 milliampere minus 10 volt. okay, plus 2 kilo ohm, and IC value is 10 milliampere, okay, plus VCB plus VBE. VB is 0.7. From here, calculate what is VCB coming.
सर सर VCE ही हमारा 0 आ जाता तो उससे भी तो हम ये चीज देख सकते हैं।
उससे बता सकते हैं। तो वही तो बताया ना, आईसी सैचुरेशन क्या है, VC 0 तभी तक सैचुरेशन क्या है, VC 0 लिया मैंने तभी तो मेरा करंट आईसी सैचुरेशन आया, उससे बड़ा है मेरा आईसी। तो उससे पता उसी से इससे डायरेक्ट पता चलता है ना भी आईसी अगर आपका VC 0 नहीं आया, 0.2 आया, 3 आया, 4 आया, तब आप क्या बोल तब आप क्या करोगे? तो तब हो सकता तब भी आपका सैचुरेशन में हो, क्योंकि इज क्लोज टू 0 ना। तो बेटर, तो ये परफेक्ट क्राइटेरिया है। अब ये निकाल लो तो ऑटोमेटिकली पता चल जाएगा आपको, ठीक है। अब VC भी निकाल लेंगे हम लोग। हाँ, अभी कितना आ रहा है?
-10.7
माइनस समथिंग लाइक दिस दिस बिकम वेरी हाई वैल्यू। आई हैव बीन रिटर्न -19। चेक करो, आगे चेक करो कितना आ रहा है फ्रॉम दिस ईयर। So this become 10, 10, cancel, very good.
sir
20,
20.7
yes, very good. 20, 20, and this become 20 or 2, 20 and plus 10, so minus 10 and minus 0.7, correct? So minus 10.7 is coming. Is it correct?
yes sir
So obviously, when if you take this IC value, then this is coming minus. So obviously, this shows this is the forward biasing NPN transistor. Okay. So this is also confirming that the operation region is saturation. Okay. Now for same, you can also find VCE. Okay. VC will also come negative. Now if this IC, if you calculate your VCE, calculate your VCE now. VCE, okay, that is what? VCC minus ICRC. Okay, so VCC is what? VCC your 10 volt, IC just now you can do 10 milliampere, and RC is your what? 2 kilo ohm. Okay, this cancel. So your VC also coming what? Minus 10 volt. So this is again confirming this is forward bias, because your VC is going here in this region, negative region. So this is a forward bias 0, but this cannot be this value. Okay, you cannot take this as an operating point, because your this loop is, VC cannot be negative, na? Because this loop restricts, load line restricts the value of VC, minimum value is 0. Okay, that means now this much value current we cannot take, because maximum current can be only this much IC saturation. Okay, and VC can be at most 0. So whenever, so for checking purpose it is okay, you have checked everything, what is a active region or forward region, but when you will give the operating point, that time you will say that my operating point Q is, my current is IC saturation, that is the maximum current. Okay, and when you put current IC equal to IC saturation, automatically your VC becomes 0, because by keeping 0 only you calculate this current. Okay, so this is your operating point. So in this particular question, the operating point will be 0, and IC saturation was, what was the value for IC saturation? 5 milliampere. For this particular question, this is the answer. Is this point clear? Any doubt? No doubt. Okay.
Sir, VCB could be found by the equation VCE equals to VBE plus VCB.
Yes. VC equal to VCB plus BP. From that itself you can find out.
Okay, sir.
So that you need to understand the terminals. Okay. So when you VCC, you lost some voltage here, that voltage will come here. This is VC. Okay. Now this VC is equal to VC in this particular question. If there is resistance, then this VC and VC will be different. So you to understand a very simple circuit. It is very simple circuit. Only in all transistor, you need to only apply KVL. Nothing. If you understand what is the base, okay, don't be afraid by this shape of this transistor. This is very simple. It's like simple resistors. You will always be having two loops. Okay, you will be having these three junctions. Actually two junctions, but three terminals. Okay, here, and then it's just you to apply KVL, and it's very simple. Simple transistor problems are very simple. Okay. Let me give you some more problem. Okay. So now we understood how to find the operating point. Okay. Just have some practice on the current equations also. Okay. So a transistor has DC value, alpha value is given 0.98. Okay. And collector reverse leakage current. Okay. ICBO or ICO, say simply ICO is given, reverse saturation current is given 2 microampere. Okay. IE is given 5 milliampere. Okay. So he says find the IC collector current. Okay. And base current IP. Find out. So what is the relation between IC and IE?
IC upon IE equals to alpha.
So you have relation. Your IC is almost equal to your alpha IE plus
Also,
ICBO,
IC.
ICO, a reverse saturation current. Okay. So alpha given, IE given, ICO given, you can find IC. Once you know the IC, you can find IB. IB is nothing. IB is your IE minus IC. Okay. Tell me the values. What is the value of IC? 4.92 milliampere coming. Four point 4.902. Are you getting this one? Or I need to solve? You have alpha is 0.98, I is 5 milliampere. Okay, ICO is 2 microampere. So what will the value? It should come like this only. Is it coming or not?
Yes, sir.
Okay. और IB कितना आएगा? IB? What is the value of IB? So IB value come 98 microampere. Okay, 98 microampere. You can check the calculation later. Okay.
Yes, sir. Coming.
Okay, this is they calling it RE. Why are they calling it RE? Okay, this is a PNP transistor. This is RE. Here you have a resistance of 2 kilo. Okay. Across the resistance, the drop is 4 volt. Okay, and here you have a battery VCC. Here you have a BEE. Okay. So in this question saying that DC alpha of the transistor in the circuit is 0.96. So alpha value is given 0.96 in the circuit. Okay, the voltage drop across this is given 4 volt. Okay, so you asking find out the base current. Okay, asking find out IB. Find out IB. Can you find out IB? So how will you calculate? See, this current is IE. Okay, I is coming here. So IC is going outside. IB going outside. Okay. So what is the value of IC? What is the value of IC? IC is flowing here. You know the voltage drop, you know the resistance. So IC is simple 4 upon 2 kilo ohm. So your IC become 2 milliampere. Once you know the IC, approximately you can calculate IE. Your IC is alpha IE. Okay, almost. So you can find IE. So IE will be what? IE will be your IC 2 milliampere upon alpha, that is 0.96. Okay. So once you know the IE, okay, so you can find IB. IB is nothing IE minus IC. Okay. Tell me the answer. IB value. Okay.
Sir, 0.833.
Check it. It is just let me check the answer. Just give me 1 minute. ओके वो तो आ जाएगा क्वेश्चन, इसमें कोई दिक्कत है नहीं. ठीक है, दिस विल कम. ओके, नो इशू.
सर यहाँ पे हमने आईसीबीओ कब निगलेक्ट किया ना,
आईसीबीओ को नेगलेक्ट किया हमने. आईसीबीओ को दे नहीं रखा क्वेश्चन में, तो नेगलेक्ट करना पड़ेगा. ओके, नाउ दिस इज a transistor has a ICBO. A transistor has a ICBO. This is your homework. Okay, ICBO is given 48 nanoampere. ICBO is 14 nanoampere. Alpha is given 0.992. Okay, so the alpha can be, question can be ideally it can be 0.99, इससे more ज़्यादा भी हो सकता है. तभी मैंने बोला था कल बीटा आपको 500 में हो सकता है. Suppose it is 0.0995, then automatically things become beta goes very high. Okay, so this is find beta. Okay, find beta 1, find ICO. If you know the ICBO, then find ICO. Okay, and B, and this is A, and B you find exact collector current. Exact collector current. Exact means you apply exact formula with reverse saturation current. Okay, and then you have to find approximate collector current. Approximate means IC equal to alpha E, or you have to reverse saturation current you can neglect. So ICBO given, alpha is given, you need to find beta ICO. Okay, so this is your homework.
सर हाँ approximate collector करंट कैसे फाइंड करते हैं?
Approximate का मतलब क्या है भी your I just now written the equation ना, your IC is what? IC is your beta IB plus, or alpha, you know, alpha IE plus ICBO. This is common base configuration. Now if you want to change this, so from here, and now you want to change this with common base. So suppose here you want to find approximate value, इसको neglect कर दो. If you neglect this one, then your IC will be what? Alpha IE. Are you getting? This is a reverse saturation current. This is microampere. You can always neglect this one. Okay. Or you now you put here a value. Just now yesterday we done. That will come beta IB plus ICO. Okay. So IC beta IB, ICO is what? ICBO upon 1 minus alpha or 1 plus alpha. What is there?
1 minus alpha.
You know all the relations. Okay, so you know alpha value, you know ICBO value. Okay, alpha value, ICBO value. So you can always find beta. So once you know the alpha, you can always find beta. Beta is what? Alpha upon 1 minus alpha. So once you know the beta, okay, you know the this ICBO. You know alpha. You can find ICO. Once you know ICO, you can calculate IC. Okay, isn't it? Everything is given, so you can find out whatever things you want from here. So beta you can find, IC you can find, exact collector current. IB, how will you calculate IB?
Sir,
IB how?
IC minus IE.
तो IE कहाँ दे रखा क्वेश्चन में? दे रखा है क्या?
Sir, IC by beta.
IC you can find.
IC by beta.
वो तो कैसे हो जाएगा? IB is given in question 30 microampere. IB is given 30 microampere. So we stop. हाँ?
ICB 48 नैनो एम्पीयर
48 ICBO 40 nanometer, IB 30 microampere. Okay, so I'm stopping here. Okay, thank you very much.
Okay, thank you.
थैंक यू सर.
Thank you.